In order to answer question 1, we have to describe what Boyle's law is, and it is the inverse relationship between volume and pressure. So as volume goes up, pressure goes down, and as volume goes down, pressure goes up, and this is related to how we are able to breathe. So if we look here, the atmospheric pressure is 760, and the interpulmonary pressure is 557. So as a concentration, you want to move from high to low. So the high pressure of the atmosphere wants to go to the lower pressure in the lungs, and this allows us to breathe in, and with lower pressure we have a higher volume in our lungs, allowing us to breathe in. And then as we look at breathing out, the pressure stays the same in the atmosphere, but our lung interpulmonary pressure goes up, having the air push out into the atmosphere, getting rid of it, so our CO2 and oxygen. And then we have to describe Dalton's law, which is the total partial pressures of mixed gases. And an example here is we have a partial pressure of oxygen, or a 3 partial pressure of oxygen, a 4 partial pressure of CO2, and that gives us a total of 7 pressure. A total of a 7 total pressure. And as we look here, this is kind of how our air is able to move through our body. So our atmospheric pressure is 159, and it wants to move to a lower concentration, and that will be in the lungs of 105. And it wants to keep moving, so it goes to our arteries, which is a lower pressure of 100. And it's still, the oxygen still wants to keep moving, and then it travels to our muscles. And there's a difference here from 1 and 40. Because a pressure of 1 means that our body is exercising, and so from going to 1 or to 100 to 1 is a large difference in partial pressures, and that allows for more gas exchange. So really, when our PO2 or partial pressure of oxygen in our muscles is 1, we're getting more oxygen to our muscles in order to help us with our exercise and create more ATP. But when we're resting, it's just 40, but it's still lower than 100, so the air or the oxygen still moves to a lower concentration. And then as our body mostly uses up the oxygen, there's still some left over in our veins, and it travels up back to our lungs. And yeah, so that is oxygen. And now as we look at PCO2, we kind of start from our lungs. So we're already left with a bit of CO2 from the air, and then we want to move to our arteries, which is just going to stay the same. It should be a 40 here, but it should stay the same because not a lot of CO2 is happening in your arteries. But when we get to our muscles, there's going to be a lot of CO2 happening because it is the byproduct of ATP and working really hard. So a partial pressure of CO2 of 46 is that you're resting, and a partial pressure of 56 is where you're working out more, creating more of that CO2. And then depending on what it is, the veins should have a lower pressure, and it travel to the lower pressure, and the veins go back to the lungs, or the vein CO2 partial pressure goes back to the lungs and back out into the atmosphere of the lower partial pressure.